Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures in computer architecture. So, we have been looking at different units in the computer and of late we have been focusing on the input output unit. With respect to input output unit, we have looked at one major mechanism, which is the interrupt based mechanism for doing data transfers. So, what we will be looking at today is another mechanism which is called as the direct memory access. So, what we want to look at is what is direct memory access, why is it required and how is it done. So, this is what will be the focus of today's topic. So, what is the need for DMA? We have already looked at this when we talked about interrupt driven input output, but let us just take a look at it again. So, there are two different ways in which we have already looked at doing input output data transfer. One is a polling based mechanism and the other is the interrupt driven mechanism. So, let us look at some of the basic mechanisms that we already have for doing input output data transfer. One is a polling based mechanism and the other is the interrupt driven mechanism. So, if we look at polling, what normally happens is that the CPU will check with each and every device if it has any data that it needs to transfer and then do the data transfer. So, this we have seen is very expensive, in the sense that a lot of CPU time is wasted in just checking with the input output devices. So, we go for an interrupt driven mechanism where when a particular device has some data that needs to be transferred, it will interrupt the processor and then the processor will do the data transfer. So, we saw that in an interrupt driven input output mechanism, there will be something called an interrupt service routine, which is responsible for doing this data transfer. Okay. But the problem here again is that the data transfer as such has to be done by the processor. That is, when an interrupt is given, at that time the processor is responsible for transferring the data from between the memory and the IO data registers. If it is an input, it will be from the input register to memory. If it is an output, it will be from memory to the output data registers. In both the cases, there is a lot of time that is wasted, and especially for high speed devices, it can be very time consuming. So, we go in for this mechanism called direct memory access, where you have a separate device called a direct memory access controller or an IO controller which can do the data transfer autonomously. What we do here is that the OS will provide the starting address in memory, that is where the data needs to be transferred, and then this controller will autonomously, without the help of the processor, right, for doing the data transfer, will directly transfer from memory to the input output data registers or from the data registers to memory. Okay. So, we call it as a direct memory access because the memory is directly being accessed by this IO controller and to transfer data from the IO data registers. So, that is normally what would happen is that we are looking at data going from the memory to the CPU and from the CPU to the IO register. So, now we are avoiding that step of going to the processor and then coming to the registers. So, here directly from the memory it goes to the input output registers and similarly from IO registers to memory. So, this is why we refer to it as a direct memory access. Now, what is the mechanism that is required for doing this kind of a direct memory access? Okay, that is what we need to now look at. So, obviously, it will require a special control unit, right, which is responsible for this task. Okay. So, we need some kind of a DMA controller which is responsible for transferring the block of data directly between the IO device and the main memory. Again, without continuous intervention by the processor. You may still require some intervention by the processor, but that is being minimized. This control unit is normally referred to as the DMA controller. Okay. So, that is the job of the DMA controller therefore to take care of doing this data transfer. What is it that the DMA controller is expected to do? Okay. So, the DMA controller now will have to perform all the functions that would be normally carried out by the processor. That is, if the processor were to do the data transfer, whatever functions it would do, all those now will have to be taken care of by the DMA controller. So, what is it that it has to do? For each word that needs to be transferred, it has to provide the memory address and all the control signals. Okay. The address to which the data is to be transferred or from which the data is to be transferred and all the control signals, in the sense that whether you need to do a read operation or a write operation, all those will have to be now supplied by the DMA controller. Okay. And to transfer a block of data, entire block of data is to be transferred, then it will have to increment the memory addresses and keep track of the number of transfers. That is, if you are, let us say, transferring 100 bytes at a time. So, the number of data, the number 100, okay, which indicates the number of bytes that need to be transferred, that has to be kept track of by the DMA controller, and also it has to make sure that it goes into the correct addresses. So, incrementing of the addresses will also have to be done by the DMA controller. Okay. So, that is, put out the right memory addresses and the right control signals, okay, in order for this data transfer to be completed correctly. That has to be handled by this DMA controller. The only thing we have to understand is, though the DMA controller can do this data transfer without any intervention from the processor, it still needs to be controlled by the processor. That is, under some program control, this DMA will have to operate. That is, the DMA controller will have to operate. So, what is it that we want this program control to do? To tell the DMA controller as to when to do the data transfer, and also to tell the DMA controller as to where exactly the data needs to be transferred. That is, we will have to specify the following to the DMA controller. Okay. So, what is it the processor will have to specify? When I say the processor, all we are talking about is some program which is running on the processor, which is responsible for initiating this DMA transfer. So, what is it we are expecting from that? It will specify, one, the starting address, that is, from which address the data has to be transferred, and then the number of words in the block, that is, if you are doing a block transfer, how many words have to be transferred, that is the second thing. And the third is the direction of transfer. What we mean by direction of transfer here is whether you want to transfer from the IO device to the memory or from the memory to the IO device. So, if you are looking at an input process, that means you are looking at data coming from the IO device to memory, and if it is an output device, then data is going from the memory to the IO device. So, whether it is an input or an output operation, that determines the direction of transfer. Okay. So, whether it is an input or an output, what is the starting address in memory from or to which data is to be transferred, and the number of words starting from that particular address. Okay. These are the three parameters that will have to be specified for the DMA controller to start its operation. Okay. So, once the DMA controller completes the data transfer, that is, it is initiated by giving these three parameters. Okay. So, once it completes this data transfer, it will inform the processor by raising an interrupt signal, indicating to the processor that it has completed its operation. Okay. So, that is the basic mechanism that we use. So, processor programs the DMA controller with these three pieces of information: starting address, number of words, and the direction of transfer. So, once the DMA controller is programmed with this information, the controller can start the data transfer. Once it is done with the data transfer, it informs the processor by raising an interrupt signal. Okay. So, this is the basic process that we have for the DMA transfer. Okay. So, let us look at a simple scenario where something like this would work. Okay. So, look at the overall architecture that we would have. You have the processor, you have the main memory connected by means of a system bus, and then we have different input output devices that are again connected to the system bus. Okay. So, let us say I have a printer, I have a keyboard, and then I have some other devices, say a network interface or some disks. Okay. Now, disks and network interface, there is a lot of data that needs to be transferred. This may happen through a DMA controller. So, I am putting a DMA controller here which interface to the network interface card. Similarly, I have a DMA controller here which is interfaced, you can see, to two different disks here, which means that both the disks can also share a single DMA controller. So, that is also possible. Okay. So, you can also see that we have not shown a DMA controller for a keyboard or a printer, because typically it is just a one byte or a one word transfer that takes place in these cases. But when you have a bulk transfer to be done, then it makes sense to have a DMA controller. So, now you can see what the DMA controller is expected to do. So, it has to take the data from the disk, okay, and transfer it to main memory through the system bus. Okay. Similarly, from the main memory to the disk, this is what would be expected of the DMA controller. But which address it has to transfer in main memory, that information has to be specified by the processor, which is what we mean by saying that the processor will initiate the DMA transfer by specifying certain parameters. Okay. So, this is the setup that we will have. So, as we can see, the DMA controller, it is connected to this system bus, okay, which is typically a high speed network. And as I said, this particular DMA controller that we have here, we have shown that there are two disks that are connected to it. Now, what we normally refer to here is, we say that now that this controller has got two DMA channels. So, one channel which connects to this disk and another channel which connects to this disk. Normally you have DMA controllers which have multiple channels, 2 channels, 4 channels and so on. So, which means that there can be one DMA controller to which you can connect multiple devices. Each device is works on a particular channel. Okay. So, in this case we have looked at 2 disks which are connected to 2 different DMA channels. Okay. So, when I say that there are 2 different DMA channels, it means that the parameters that we require, right, that is the registers to store the memory address, word count and other status and control information for each channel are duplicated. So, which means inside this controller now I will not have just one set of register for the starting address, word count and so on, but I will have 2 sets of registers. One set of register for one particular channel and another set for another channel. So, it is almost like saying that I have 2 different DMA operations that are supported by this controller, and both these can take place simultaneously, in the sense that the processor could initiate 2 different data transfers and the DMA controller will be responsible for doing these data transfers one after the other. Okay. But the processor need not worry about when exactly these data transfers are taking place, that will be handled by this DMA controller. Okay. That is the kind of setup that one would typically have. The way the DMA controller will actually access the system bus. So, you can see, remember that the system bus is shared by the processor as well as the DMA controller now. Normally it would be the processor which is responsible for the system bus, and it is the one that will initiate the data transfers on the system bus. Okay. So, we normally say that the processor is the one that is in control of the system bus, but now when we say that we also want the DMA controller to access the main memory through the system bus, it means that the DMA controller also should have some kind of a control over accessing the system bus. That is, the processor should give up its control and the DMA controller should take up the control. Okay. So, that is, so this fellow has to give up control of the bus and this fellow has to take control of the bus. So, how do we expect this kind of a giving up and taking up of control to happen? There are 2 different ways in which this is normally done. One is that the processor and the DMA controller use the bus in an interwoven fashion. That is, normally it is the processor which will have control of the bus, and when the DMA wants to access the bus, it puts out a request to the processor called a DMA request, and the processor will release the bus for a short duration, for let us say 1 cycle or whatever, during which the DMA controller can access the bus. Okay. This is one way in which it is done. In this case, when it works in this particular manner, the DMA controller is said to steal the memory access cycles from the bus. So, we call this interweaving technique as cycle stealing. Normally the processor has the bus, but when a request comes from the DMA controller, it just releases the bus for a cycle or for a few cycles, and those few cycles are used by the DMA controller to do a particular data transfer. Again and again, therefore, the processor will keep having the bus and this DMA controller will keep requesting the bus, and whenever there is a free cycle, it kind of steals that cycle. So, we call that as a cycle stealing mechanism. Okay. But normally the cycle stealing mechanism is a little slow. So, we go for what is called as a block or a burst mode of data transfer. So, here what we do is the DMA controller is given an exclusive access to the bus, okay, exclusive capability to completely initiate transfers on the bus. Okay. And so, what we are talking about here now is that it is not just that the processor is in control of the bus and then the DMA controller takes access to it, but now what we are saying is that both processor and DMA can have equal share in terms of the bus, and whoever wants to become the master of the bus, who wants to take control of the bus, can take control of the bus and do the data transfer. So, we will take a short break now and then come back and look at the details of the burst mode of data transfer takes place. Welcome back after the break. So, we have been looking at how direct memory access is working, and we looked at one mechanism called cycle stealing, through which a DMA controller can get hold of the bus to do its data transfer. Another more significant approach is what we call as the block or the burst mode of data transfer, where the DMA controller is given access to the bus for doing a complete block transfer or a burst transfer. So, what I mean by a burst transfer is that a burst of data, that is a whole block of data, can be transferred in one shot. That is, a few cycles, for a few cycles the bus is given to the DMA controller and the DMA controller does its complete data transfer. Okay. Now, when you say this, that the control is given to the control of the bus is given to the DMA controller, it means that now we need to have a mechanism to determine who will have the bus at any given point of time. Okay. So, that brings us to another topic which is called as bus arbitration. Okay. What we mean by arbitration is that the normal term arbitration is normally used when there are two parties looking for a particular resource, and you want to have an arbiter or an arbitration mechanism which determines who will get access to that particular resource. Okay. So, here now we are talking about the processor and the DMA controllers both wanting to initiate data transfers on the bus and access main memory. Okay. So, now who is going to be given the bus? Okay. That has to be determined by a mechanism called bus arbitration. Okay. So, and normally the term that we use for the person who is having control of the bus is called as the bus master. Okay. So, the device which is allowed to initiate transfers on the bus at any time is now called the bus master. So, now we are having a situation where there can be more than one bus master. So, typically we would have only the processor as the bus master and everybody else just requesting the processor to do the data transfer on their behalf. Now, we are talking about any device, either the processor or a DMA controller as becoming the bus master and having the capability to initiate data transfers. Okay. So, now this process, okay, of determining, okay, which device can become the bus master and which device is now going to be allowed to do the data transfer next, okay, that is what we call as the bus arbitration mechanism. Okay. So, what does this require? For bus arbitration to work correctly, we need to know who is the current bus master, and when the current bus master relinquishes the bus, that is, it gives up the bus, which means it is no longer the bus master, it relinquishes its status as the bus master, another device can take up the status as the bus master and do the data transfer. Okay. So, this is what we mean by bus arbitration. So, what we basically need to remember is there is somebody can become a bus master, and when that bus master relinquishes its status, another device can become the bus master and do the data transfer. Okay. There can be any number of bus masters now. So, let us say for instance there are 3 different DMA controllers. So, the 3 different DMA controllers and the processor, any of these can become the bus master. So, now we have to determine how the bus is shared between these different bus masters. There are normally 2 schemes that are used. One is called the centralized arbitration mechanism and the other is called as a distributed arbitration mechanism. Now, in the centralized arbitration mechanism, what we have is we have a special device called the arbiter, okay, a single bus arbiter which is responsible for performing this arbitration. Okay. So, this is a centralized device, okay, a special device. Now, this special device is the one which will take the requests from the different units which want to become the bus master and then determine who has to become the bus master. Okay. So, it is a centralized unit which is responsible for doing this arbitration. This is one style in which the arbitration can be done. Another mechanism for doing the arbitration will be the distributed arbitration mechanism. Here, all the devices participate together in the selection of the next bus master. That is, every device will put out some information and then we will look at what is the information on the bus and together in a cooperative manner determine who has to become the bus master. Okay. So, we will take an example of both centralized and distributed arbitration mechanisms and see how it basically works. So, let us look at this centralized bus arbitration scheme. So, in this scheme we are assuming that the bus arbiter is there as part of the processor. Okay. So, in this case what we have is you can see that there are some control signals which are bus related signals or bus access related signals which are used over here, and that it is only those signals that we are showing here. So, in addition to this, of course, you will have your bus address signals and data signals and so on, but what we are showing looking at here is 2 signals, one called a bus busy signal and another called a bus request signal. Okay. Of course, you can see there is one more signal here called a BG1 which is called as a bus grant signal. So, you can almost identify from the 3 terms as to what is basically going to happen here. There is something called a bus busy which indicates whether the bus is currently busy doing some data transfer or not. And then we have a request signal. This bus request signal is normally a signal which is asserted by one of the DMA controllers which requires the bus. Okay. So, bus request signal which comes to the processor or to the arbitration unit which is present in the processor, and then in response to the bus request signal if the arbiter decides that the bus can be granted to one of these DMA controllers, then it puts out what is called as the bus grant signal. You can see that there is a BG1 signal which is coming out from the bus grant from the processor, and this is given to the DMA controller 1. Now, if the DMA controller 1 wants to use the bus, it uses the BG1 signal and takes control of the bus. Otherwise, it will pass on the grant to the next DMA controller. You can see that this passing of the bus grant signal from one controller to another controller is very similar to the daisy chaining technique that we saw for the interrupt technology that was used when we were using interrupts. So, it is a similar mechanism, that is a daisy chaining of the bus grant signals that is used, or you may also have separate bus grant signals given to each of the devices, and you may have separate bus request signals coming from each of the devices. Both these mechanisms can be used when we are looking at a centralized bus arbitration scheme. But let us look at just a single bus request signal and look at how this scheme will work. So, as I said, the bus arbiter may be the processor itself or a separate unit which is connected to the bus. In this example, I am assuming that the bus arbitration is also done by the processor itself. So, which means the processor knows when it has to access the bus, and any other access which has to come by means of a bus request which comes from the particular device. So, DMA controller 1 or DMA controller 2 will send out its request by means of this bus request signal over here. Okay. So, the DMA controller is requesting the control of the bus by asserting the signal called the bus request signal. So, BR line is asserted. So, our assumption here is, since the processor is the one which is also doing the arbitration, normally it is the processor which has control of the bus and will relinquish its control only when it gets this bus request signal. Okay. So, given that scenario, so let us look at what the processor is expected to do. That is, the processor now has got a bus request signal from one of these devices. So, in response, what are we expecting the processor to do? It will activate the bus grant signal or the BG1 line. Okay. What does this indicate? Indicating that the controller now may use the bus when it becomes free. Okay. So, when I say when it becomes free, what we mean here is that, remember, there is the signal called a bus busy signal. This signal will indicate whether the bus is currently free or whether some data transfer is taking place on it. Okay. So, when a data transfer is taking place, obviously the controller cannot use it, but once the data transfer is over, okay, the busy signal will indicate that the bus has become free, and then the DMA controller can initiate its data transfer. Okay. So, this is what we mean when we say that when the bus is free, it can start the data transfer. So, now the BG1 signal is connected to all the DMA controllers, as I said, in a daisy chain fashion. So, in a daisy chain fashion indicates that, so if that particular device wants to use it, it will use it. If it is not using it, it will pass on the grant signal to the next device in the chain. Okay, that is how it works. Okay. Now, the bus busy signal, if it is 0, it indicates that the bus is busy. When it is 1, it indicates that the bus has become free. Okay. Series of control signals and the sequence in which these different operations would typically take place. So, if you look at the sequence of events that take place for this bus arbitration, we can understand it from this timing diagram that we have here. So, let us say, for instance, the bus is busy, there is some data transfer that is going on, and a particular DMA controller, say DMA controller 2, asserts the BR signal, the bus request signal. Okay. So, when it asserts the bus request signal, you can see that after some time the processor is willing to grant the bus. So, it asserts the BG1 signal. So, the BG1 signal goes high, you can see over here. Now, since it is DMA controller 2 which has asserted the signal, it passes it on to the next device. So, now from BG1 it is BG2 which goes active. Okay, you can see that after some time of BG1, BG2 goes active. So, when BG2 goes active, it is an indication to the DMA controller 2 that it has been granted the bus. Okay. So, now what are we expecting BG2, that is the second DMA controller, to do now? To take up the bus as soon as the bus becomes free. Okay. So, now you can see that over here the bus busy signal is becoming high here, that is from 0 it goes to 1, indicating that the bus now is released by the processor. So far it is the processor up to this point, it is the processor that has access to the bus, which means it is the bus master, and now it is relinquishing the bus by freeing the bus busy signal. Okay. So, as soon as the bus busy signal goes high, now the DMA controller 2 can take over the bus. Okay. So, now what it does therefore is, as soon as it gets the piece of the bus busy signal, it now lowers its bus request signal, that is, it says that okay, now it has got the bus, therefore it releases the bus request that it has earlier put in, and after the bus request is released, this can now take over the control of the bus. So, now it is a DMA controller which will activate the bus busy signal saying that the bus is now busy, and then for the duration that it is doing the data transfer, it will now become the master of the bus. So, the DMA controller is 2 is the master of the bus for this duration now. Okay. So, once it has finished its data transfer, it will now release the bus and make the bus busy signal high. After it has released the bus busy signal, okay, now the processor again will take control of the bus and start doing the data transfer. And meanwhile, you can see that once the bus request is taken off, the grant signal also will be taken off. So, BG1 will be taken off, and once BG1 is taken off, BG2 is also taken off, and then the processor will get access to the bus because there are no other requests that are pending. If another controller had made a request, then depending on which has a higher priority, whether it is a processor or the controller, the bus will be given to that particular processor or will be given to that particular controller device. So, this is basically how the centralized arbitration scheme will work. So, to summarize, what we have looked at in today's lecture basically is, we have looked at DMA, the direct memory access mechanism, and we looked at the details of how it works. That is how the different parameters have to be specified into the DMA controller and how the DMA controller does the data transfer. Now, with respect to doing the data transfer, we said there are 2 mechanisms. One is the cycle stealing mechanism, and then the other is a burst mode of data transfer, which requires control of the bus. So, in which case it brought us to the topic of bus arbitration. We looked at in detail on the centralized bus arbitration mechanism. We also mentioned that there is a distributed bus arbitration mechanism, but we looked at how the centralized bus arbitration mechanism works. So, a few questions to review today's contents. Question number 1, what are the parameters that the DMA controller should be programmed with? Question number 2, what is meant by burst mode of data transfer? Question number 3, how does the central arbitration scheme work? Question number 4, what are the uses of bus grant and bus busy signals? Thank you.